Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you out a little bit with number 10 here on your homework. Now first of all, I'm going to change the directions a little bit where it says use the theorem of Pappus to find the centroid of the given triangle. We're just going to do this by direct integration. So this triangle right here, this point goes through the point 0b, this point goes through the a0. The centroid is over here somewhere. It's got some coordinates, x bar, y bar that we're going to try to find. And I'm going to go ahead and start by drawing a differential element, a rectangle. You can draw it either horizontal or vertical. It'll work out just fine either way. So I'm going to go ahead and draw a horizontal rectangle. I'm going to imagine the width here is dx. We're going to need the length. Now the length is equal to this value right here. We're going to need a function to describe that. So I'm going to work on this this function right here. This is a linear function, so it can be written y equals mx plus b. Because it goes through the point 0b and the point a0, the slope is going to be minus b over a. And the intercept I can just read right off the graph. Oddly enough, I had used this for a generic intercept here, but this was actually called the point 0b in the book. So there is our function, and that function is going to equal the length of this rectangle. That's going to be true anywhere along this path. Centroid of the rectangle is here. This is the x coordinate for the centroid of the rectangle, and that's just x. This small green distance here is the y bar for the rectangle. Now you'll notice that is halfway between here and here, so that is going to equal this divided by 2. Alright, so when we calculate the centroid, we're going to be averaging the x values, and then we're going to again multiply by area, length, times width. These are then added up, and if I'm integrating with respect to x, x is running 0 to a. We have to divide out the total area, which is going to be the integral 0 to a of length. Oops. Oops again. Times width. And if you work this correctly, I believe you should get a over 3 out of this if you work that out, that integral correctly. Right. The setup for y bar. Right, now we're averaging these small distances here, which are equal to this. Then you have to give it a weighting, so we'll multiply by the area, which is the length, times the width. These need to be added up, and then again divide out the total area. You know what, I'll just put a total here, where this is equal to a total. That's good enough. If you work this one out correctly, you should get b over 3 out of that. And there's the setup for number 10.